Hello everyone! Welcome back to my YouTube channel. Again, this is Sir Raubensun, your partner in learning mathematics. But before I begin my discussion, I would like to remind you to please, while watching this video, you should take down notes to all the important details. And I do hope before you click this video, you have a notes on my previous video. Example, review on trigonometry and rules and trigonometric function, because those knowledge learned in my previous video is important in understanding this video well. I do hope you take down notes while listening to my discussion. Okay, we are done with our example number 3. That is the limitation of tan 4t over sine 3t as t approaches to 0. As you can observe in this example, we've used the tangent function, where in fact I presented only 3 different special limit rules that is in the form of sine and cosine. So now, how are we going to solve this kind of problem if we involve tangent? Okay, as you can observe, I presented to you in my video entitled Review on Trigonometry that all trigonometric function can be expressed as a function of sine and cosine. If you still remember that tan x is equal to sine x over cosine x. Therefore, sine 4x is equal to sine 4x over cosine 4x. Whatever you add here, you must have to input that one in the sine and cosine. Therefore, tan 4t can be expressed as a function of sine and cosine. Therefore, it will become as the limitation of tangent 4t, that is the same as sine 4t all over cosine 4t all over this one, that is sine 3t. Okay, as you can observe, everything now is in the form of sine and cosine. So meaning, after that one, take note, just still observe if that is in determinate form, because once we use the direct substitution method, that will become 0 over 0 or indeterminate form. You have to find ways in solving such. So this time we already converted this one. So now we have in the form of sine and cosine. Therefore, our new function now is the limitation of sine 4t all over cosine 4t all over sine 3t as t approaches to 0. Okay? As you can observe, we have double fractions. So once we involve double fractions, we have to simplify that one. Again, how to solve double fractions? So we believe this is our numerator. You copy your numerator, sine 4t all over cosine 4t. You change division into multiplication, that's right, and get the reciprocal of sine 3t. We believe sine 3t, that is a decimal term. So find the reciprocal. We believe we have 1 over there. So that is 1 over sine 3t. Okay, so that is now the new form. Copy numerator, change division into multiplication, and get the reciprocal of your denominator. So that is now our new functions. Okay, so it will become the limitation of this one, sine 4t over cosine 4t times 1 over sine 3t as t approaches to 0. The question is, can we use direct substitution method in this form? No, simply because it will become still indeterminate form. So just continue simplifying, and we believe we can able to separate this one. That is now in the form of this one. We can able to separate that one as sine. I'll just write it here. We can able to separate this one as the limitation of wait, bring down sine 4t multiply to 1 over cosine 4t, because if I'm going to use multiplication here, still the same. Okay, so copy this part. So times 1 over sine 3t as our t approaches to 0. Okay, so from here we converted in this form, and from this form we use the double fraction method, or just like that. And from here we write it here as the limitation as t approaches to 0. And from here, we separated everything. Okay? So, we have this new form. I'll erase this part now. Where's my eraser? Wait. I'll erase this part for you. Okay, so we have this new form now. This is now the new form, so let's write it in this part. So that is the limitation of sine 4t times 1 over cosine 4t times 1 over sine 3t as our t approaches to 0. Okay, I'll erase this part. Okay, so the question is, can we use direct substitution method now? No, simply because still it will become indeterminate form. This is 0, 0 times 1, that is 0 times another 0 over 0, so that is still indeterminate form. So continue simplifying. As you can observe, I have now sine 4t and 1 over sine 3t. So you can able to simplify that one using the theorems that I presented to you, that sine x over x is equal to 1, the limitation of this one, and same thing as x over sine x is equal to 1. So meaning, I have to find ways to have a denominator as equal to 4t, and same thing to make it 3t over there. Okay? Just continue simplifying. In short, I have to find ways for sine 4t. So that is sine 4t. In order to make use of this one, I have to multiply both numerator and denominator as 4t over 4t, because I need 40 in my denominator for me to make use of this theorem. Okay? So now, so it will become sine 40 times 40, that is 40. You have to multiply that one, sine 40 times 40, that is 40 sine 40 over 40. As you can observe, we can able to use this theorem. Same example that I presented to you. Okay, let's continue that one. So you can observe, I have this my new form of a function. So as you can observe, they are no separate. We can able to use this one as using this theorem, and of course this one using this theorem. Okay, let's solve it one by one or individually. So let's get this one for sine 40. How am I going to make sine 40 just like this in order for this the limit equal to 1? So since I lock 40 in the denominator, I have to divide 40 over multiply 40 for numerator and another 40 for denominator, since I have 1 in my denominator. So 40 times sine 40, that is 40 sine 40. Same thing that same that I did in the first two examples. So 1 times 40, that is 40. Okay, so we can able to separate this one as 4t times sine 40 over 40. As you can observe, we can able to use this one. You can able to use the theorem that I presented to you in this form. Sine 40, 40, they are the same. Okay? How about here? Do we have to simplify? Do you have to simplify 1 over cosine 40? No, we don't have to simplify that one. Because once you use direct substitution, if you're going to check in the table that I presented to you, that I sent in your group chat, that is 1 over cos 4 times 0, that is 0, right? So cosine 0, what is the value of cosine 0? If you're going to check that one in your calculator, and also in the table that I presented to you in your GC, cosine 0 is 1. So meaning, this one, that is equal to 1 over 1 or 1. So you don't have a need to simplify because that is not undefined. It has value, okay? What are you going to do is to simplify this one. This is 1 over sine 3t. Okay? 1 over sine 3t. As you can observe, we can able to use this one. We can able to use this theorem. Same with theorem number 1. What do we need in our numerator to make our numerator equal to the inside function of your sine? Meaning, you have to multiply 3t over 3t, both numerator and denominator. The same thing, it will become 1 times 3t, that is 3t over sine 3t times 3t. That is 3t sine 3t. And we can able to separate that one. Same thing with here. As you can observe, 3t is our in the denominator. So it will become 1 over 3t times 3t over sine 3t. If we're going to get the limit of this function, we just separated this one, okay? Because 1 times 3t, 3t, 3t times sine 3t, that is 3t sine 3t, okay? So now we can able to separate that one. As you can observe, if we're going to get the limit of this one as t approaches to 0, that is equal to 1. Same thing here, as 3t over sine 3t, same thing with this one, that is equal to 1. So meaning, we can able to make use of all the limits that I presented to you. So meaning, sine 40 now has a new phase. They are now equals. This one and 40 are now equal. Same thing with 1 over sine 3t is the same with this one. So now, let's just substitute the new form. Okay, I'll erase this part now. Okay, again, this is here, and 1 over sine. Again, you don't have a need to convert this one because it has value already. Okay, so this is now the limitation of, what is the new value of sine 40? That is 40 multiplied to sine 40 over 40. This one, what is the limit of this one? Once you substitute 0 in the denominator, it will become 1 over cosine 0. What is cosine 0 again? That is 1. So meaning this is times 1 or just nothing, or times 1 times 1 times, what is the new form? 1 over 3t times 3t over sine 3t. Okay. Again, why it is 1 now? Simply because we substituted 0 because it has value and it has already value. So meaning the value is 1 because 1 times 4, that is 0. So it will become cosine 0. Cosine 0 is 1. So 1 divided by 1, that is 1. That makes this 1 here. So I have to erase this one now. Okay, so let's try to find the limitation of all the terms here. Okay, as you can observe, what is the limit of this term now? Limitation of t, a limitation of sine 40 as t over 40 as t approaches 0. This is now equal to 1. So meaning it will become the limitation of 40. What is the limitation for this one? That is 1. Copy times 1. 1 over 3t. What is the limitation of 3t over sine 3t? Same with this one, that is also equal to 1. Okay, as you can observe, 40 times 1 times 1, still 40 times 1 as t approaches to 0. Okay, we're not done yet. Let me show you here in this part. Okay, so now, as you can observe, the remaining term here is the limitation of 4t times 1 over 3t as t approaches to 0. Why? Because 40 times 1, 40. Times 1, 40. Times 1, 40. Times 1 over 3t. Times 1 over 3t. Okay? So as you can observe, if you're going to use direct substitution method, we already cancel the sine and cosine functions. Because this is already 1 using the theorems that I presented. This is also 1 using the theorems that I presented to you. So meaning, if you're going to use direct substitution here, it is still indeterminate form because 40 times 1, it will become 1, a limitation of 40 over 3t. Because 40 times 1, that is 40. 1 times 3t, that is 3t as t approaches to 0. Once you use direct substitution method, 4 times 0, 0, 3 times 0, 0, that is 0 over 0, meaning we're not done yet. As you can observe, we can able to cancel the t or the variable 3. We can able to divide. The remaining term now here is the limitation of 4 over 3 as t approaches to 0. What is the limitation of 4 over 3? Take note, 4 over 3 is a constant, meaning we can able to use the constant function, and that is 4 over 3. Therefore, the limit of this function is 4 over 3. That's how you do everything, okay? You can able to find ways just to use the rules that I presented to you. It's all up to you. So for example, number 3, this is how you solve this one, okay? Okay, without further ado, let's solve example number 4. What if your function looks like this? The limitation of 1 over cosine 3x over 5x as x approaches to 0. Okay, this time is now the cosine function. I believe I presented you special limit theorems for cosine. That is the limitation of x minus cosine x. No, this is 1 minus cosine x over x. The limitation is equal to 0. Okay? So therefore, it may make it sure that the term inside the cosine function is the same with what's in the denominator to conclude that the limit is 0. As you can observe, I have your cosine 3x, but my denominator is 5x. So what are you going to do is to make this one 3x at the same time. Okay? So how are we going to solve that one? We have to find ways in solving this problem. Okay, so now, let's try to solve it this way. Okay, so I believe I can able to separate this one. I can able to factor 5 outside here. So since that is in the denominator, the numerator of this one is 1 over 5. So therefore, it will become the limitation of factor out 1 over 5 times 1 minus cosine 3x. What is the remaining here? We have still x. As x approaches to 0. Okay? So now, in this example, I just separated. I didn't do anything operation in this problem. I just separated the problem. So because 1 times 1 over cosine 3x, still 1 over cosine 3x. And 5 times x, still 5x. I just separated. So meaning, I have to find ways to make the denominator of this term 3x. You can able to use this one. Take note that I have an invisible number 1 beside. So same thing that I used in solving the sine and cosine in my previous example. I just have to multiply what is needed. I need constant 3 in denominator. So meaning, I have to multiply this one by 3 over 3. Why 3 over 3? Is it mathematically correct? Yes, because I need 3 here, and 3 divided by 3, that is 1, and we have invisible 1 beside each functions. Okay? So what we're going to do is to simplify. Just do multiplication. This is now the limitation of 1 over 5 times, you have to multiply 3 in all the terms here. So that is now 3 times 1 minus cosine 3x all over 3 times x. That is now 3x. Okay, so I just do multiplication in that part. As x approaches to 0. Okay. So you can observe, 3x here and 3x here are now equal. Meaning, we can able to make use of the rules that I presented to you. So meaning, this is now 0 here. The limit here is 0. And we can able to do simplification in this part. Okay? So let me erase this part for you. Again, do not forget to write. Okay? Okay. So this is now the new form of the function. Take note, I can able to multiply 3 times here, 1 times 3 here, so I can able to move that one. They are just the same. So it will become the limitation of 3 over 5. I just multiply 3 times 1, 3 over 5, times, what's the remaining here? That is 1 minus cosine 3x all over 3x. As x approaches to 0. Okay, so that is now the new form of the function. Okay. So now take note that we can able to use the rules now in solving this one. So they are now the same. Special limit here number 3. that 1 over cosine 3x over 3x is equal to 0. So take note that once I use the product rule here, limitation of 3 over 5 as x approaches to 0, 3 over 5 is a constant. Therefore, the limit is 0. Constant 3 over 5. So that is 3 over 5 times. Once you do this direct substitution method here, limitation of 1 over cosine 3x over 3x as x approaches to 0, the limitation is 0. Okay, using the rules that I presented to you. So 3 over 5 times 0, that is 0. Okay, therefore, the limit of this function is 0. That's how we solve example number 4. Okay, hello everyone. This is the last example for this video, including the special limit of limit theorem. So this is how we solve everything. So my example number 5 looks like this. The limitation of x, limitation of 1 minus cosine squared 2x all over 4x as x approaches to 0. Again, if you're going to use direct substitution method, your denominator will become 0. And that is undefined. We don't want it to happen every time we solve limits. Once it is undefined or indeterminate form, we have to make ways or find ways to find the limit of that function. Okay? So now, let's simplify. But before that one, let's define the new terms or function here involved in this problem. Cosine squared 2x. Again, when we say cosine squared 2x, that is equal to how many cosine 2x? That is, we have 2 cosine 2x. Cosine 2x multiplied to cosine 2x. That's how cosine squared 2x means. Meaning we have two same cosine 2x. Okay, so meaning we have 2 cosine here and we have 1 here. So you can observe the one way to make it to make the theorems useful is only the function of cosine, the 1 minus cosine x over x. As x approaches to 0, that is 0. That is only applicable in this example. But how are we going to use that one? Take note that cosine squared 2x is a perfect square. And 1 is also a perfect square. If you still remember, example, y squared minus y squared, is x squared a perfect square? Yes, that is a perfect square. Is x squared a perfect square? Yes. Is y squared a perfect square? Yes. If you still remember the sum and difference of this square, we can able to find the factor of this one. X squared, that is x, since we have minus here, plus and minus. And the squared of the root of y squared, that is y and y. So we can able to factor that one if and only if we have 2 terms and each term is a perfect square and we have a subtraction in between. Therefore, we can able to factor this one as the sum and difference of 2 squares. Same thing here. Is this a perfect square? Yes. Is it a perfect square? Yes. So we can able to factor that one out. So meaning, excuse me, so the limitation of this one, the factor of this one is, what is the root of, what is the factor of 1? Is 1 a perfect square? Yes. The root is 1 and 1. Since we had minus at the middle, that is plus and minus. What is the root of cosine squared 2x? Take note that cosine squared 2x is equivalent to cosine 2x and cosine 2x. So we can able to separate the two. So cosine 2x and cosine 2x. So in short, denominator. Okay? So 1 minus cosine 2x. So we can able also to separate that 1. 2 times 2x. Because 2 times 2x, that is 4x. Why did I separate that one? Simply because I can use 2x here. So you can able to use the limit theorems that I presented to you. What limit theorems is that? The limitation of 1 minus cosine x all over x, the limitation is equal to 0. So I have to make use of that one. That's why I use 2x, because I have 2x inside of cosine 2x. That is why I separated that one. Okay. So now, as x approaches to 0, continue simplifying. Again, where did I get this one? By factoring. Okay, again, so what we did is we use the, we factor this one out since 1 is a perfect squared, cosine squared 2x is a perfect squared, just like what we did here, the sum and difference of 2 squared. What is the root of 1? That is 1, 1. What is the root of cosine squared 2x? That is cosine 2x times cosine 2x. Since we have minus in between, that is plus and minus, the sum and difference of 2 squares. So now, in my denominator, I separated 2 times 2x. Why did I do that one? As you can observe, one term here, one binomial here, is 1 minus cosine 2x. And I need 2x, so I can use this theorem that 1 minus cosine x over x is equal to 0, or the limit is 0. Okay, so I can able to do that one. Therefore, I can able to separate these terms. It will become the limitation of 1 plus cosine 2x over this one 2 multiply to 1 minus cosine 2x over 2x. Okay, so meaning I can able to use as x approaches to 0. Meaning I can able to use this one here, this theorem. Okay, that is why I separated. That's how you make waste. Okay, so as you can observe, do I have to make this one useful? No, you cannot do that one because can you make use of this one in this term? No, you cannot do that one simply because this is the operation between is addition. The rule is subtraction. So meaning you cannot do anything about it. So since I cannot do anything about it, do I need to use direct substitution? Let's try. As you can observe, if you're going to use direct substitution, it will become 2 times 0. This is 0. 2 times 0. And 2 times 0, that is 0. We believe that cosine 0, based on the table, if you use your calculator, and also the table, cosine 0 is equal to 1. That is always equal to 1. Therefore, it will become 1 plus 1. 1 plus 1, that is 2. 2 divided by 2, that is 1. And the limitation of 1 is 1. As x approaches 0, that is constant rule. Again, how did I make it 1? You substitute 0 to here, that is 2 times 0, that is 0. 0, cosine 0 is equal to 1. 1 plus 1, we have 1 here, that is 2. 2 divided by 2, we have 1. That is 1, 1 here. And the limitation of 1 as x approaches to 0, that is 1. Constant rule. Okay? Times this one, limitation of 1 minus cosine 2x over 2x. Since the term inside cosine is 2x is equal to the denominator, there are 2x over 2x. So we can able to use this one. Therefore, the limit of this entire term here is 0. And 1 minus 0, that is 0. Therefore, the limit of this function is equal to 0. That's how we solve that one. As you can observe, I use the three different special limit of trigonometric function. What are you going to do is to find ways to make use of the 3 different limit theorems. Okay? Just like if you use direct substitution method, it will become indeterminate form. You find ways in using that one. So that is my and my video ends here at example number 5. Okay? So again and again, if you still have hard time understanding this video, do not forget to look for other references that may help you, or you may just replay the video. Take it slow, learn slowly. Okay? Because learning doesn't take that fast. Okay, so again and again, I am Sir John Raubensun, your partner in learning mathematics. Do not forget to click the subscribe button and give me a thumbs up if my video helps you. Okay, see you in my next video. Bye-bye!